Decades of costly failures have taught security engineering what works. Code reviews before deployment, access controls preventing unauthorized actions, least privilege limiting blast radius. These patterns exist because early systems failed when enforcement happened after problems instead of before. Developers commit broken code, production broke. Systems granted excessive permissions, data leaked. Services ran with unnecessary privileges, attackers exploited gaps that should have never existed. The lesson was straightforward. Enforce boundaries at commit time. Prove the right to act before action happens. Generate audit evidence as operational byproduct, not separate documentation. AI agents are making the same mistakes. We applied narrative governance instead of enforcement. Policies saying what systems should do, logs documenting what systems did. Nothing proving systems had the right to act when decisions bound to reality. Here's what contextual boundaries look like when you engineer them into inference workflows. This is Engineering Enforcement into Inference, Governance Part 14. How decades of security engineering translate to AI systems that can prove the right to act. Section 1. What contextual boundaries actually are. Contextual boundaries are enforcement mechanisms embedded into AI inference workflows that answer three questions before a system acts. First, is this action within the scope of authority granted to the system? Second, does this system have verified access to the data and resources required for this action? Third, can this system prove in real time that executing this action is admissible under current policy? If the answer is yes to all three, the system acts. If the answer is no to any, the system either escalates to human authority or refuses the action entirely. This is not post hoc review. This is pre-commit enforcement. The same discipline that prevents developers from deploying code without review, blocks users from accessing data without authorization, and limits service accounts to minimum and necessary privileges. Applied to the moment an AI system decides to issue a refund, place an order, launch a campaign, or modify a customer record. Section 2. Why contextual matters. Every enterprise implements boundaries differently based on constraints that frameworks cannot predict. A financial services company enforcing transaction limits for fraud prevention has different boundary requirements than a healthcare system protecting patient data under HIPAA. A manufacturing operation coordinating autonomous supply chain decisions has different needs than a SaaS company managing customer support escalations. The three enforcement questions remain constant. The answers change based on regulatory environment, risk tolerance, data sensitivity, operational velocity, or organizational structure. That is why contextual boundaries are engineered, not configured. You design within the constraints you actually have rather than applying generic guardrails and hoping they fit. At an EU telecom, compliance boundaries were baked into deployment pipeline architecture. Access controls were foundational to the infrastructure, not added after security review. When regulatory requirements changed, the architecture adapted without rebuilding because boundaries were engineered for regulatory evolution from the start. At an SMB security provider managing 80 data centers across 3 continents, operational boundaries generated audit artifacts as byproduct of infrastructure monitoring. Security logs, performance metrics, and compliance reports flowed automatically from systems already built. Enforcement happened in real time. Evidence appeared without additional documentation effort. At a SaaS company transforming deployment from annual to biweekly cycles under strict security requirements, approval boundaries matched business velocity. High-risk features got senior oversight. Routine updates got automated validation. The boundaries accelerated deployment rather than blocking it because they were designed for the specific constraints of technology operations under pressure. Those patterns transfer. The implementation details do not. That is contextual engineering applied to boundary design. Section 3. The 3 enforcement questions in place. A customer service agent receives a refund request. Before the system processes the transaction, enforcement checkpoints fire. Scope validation asks whether issuing refunds falls within this agent's granted authority. The agent identifier maps to a role definition. The role includes customer account modification with financial impact limits. The requested refund amount falls within the approved range. Scope checks pass. Access verification asks whether the agent has legitimate need to access the customer's financial record required to process a refund. The agent is assigned to the customer support tier. The customer account is not flagged for fraud review. The agent session is authenticated and current. Access checks passed. Admissibility evaluation asks whether the current policy allows this transaction under present conditions. The customer account is in good standing. The refund reason code matches approved categories. No recent refund activity suggests pattern abuse. The transaction timestamp falls within business hours when human oversight is available if needed. Admissibility check passes. All 3 questions resolve to yes. The system issues the refund. The customer sees resolution in 4 seconds. The enforcement layer fired 3 times before action completed. Nothing in the customer experience reveals that boundaries were checked and passed. Total enforcement latency was 47 seconds. Invisible to the user, automatic for the system, auditable for compliance review. Section 4. How this connects to the systems you've built. The machine learning infrastructure you built in the machine learning series and the LLM pipeline you built in the model series both included validation, traceability, and auditability as embedded layers. The data pipeline validated schema compliance before ingestion. The feature store tracked provenance from source to training data. The model registry logged which version served which inference request. The monitoring infrastructure detected drift before users experienced degradation. The evaluation framework established quality baselines that production output was measured against continuously. Those were contextual boundaries for machine learning systems. Not called that, not framed as enforcement, but functionally identical. Checkpoints embedded in the workflow that validated whether actions were safe before consequences occurred. Evidence generated as operational byproduct. Boundaries that enabled velocity by making safe deployment the path of least resistance. Contextual boundaries for autonomous AI systems require the same architectural thinking applied to decision commit points, not bolted into finished systems. Engineering into the inference pipeline from the start. Section 5. What's next? The remaining articles cover the technical architecture of decision boundaries, how scope, data access, and admissibility checks are implemented as code rather than policy, how the 3 outcomes model of allow, escalate, refuse resolves at commit time, how boundaries add to different agent types, risk profiles, and operational contexts without requiring manual reconfiguration for every use case. Enforcement mechanisms that turn contextual engineering from concept into executable control.